Alright, good afternoon. My name is Kevin. This is Mike, Adam, and Herbert, and our product is the ice cycle system. The rink at St. Mary's has its ice surface cleaned daily by a Zamboni. Now the machine's operator is required to fill the tank of the Zamboni with fresh water a minimum of 3 times a day. So that amounts to 1,800 liters of water used in a day, which if you add it up over the course of the year, that's almost 700,000 liters of water. To paint the picture a little bit more clearly, that's 1.4 million regular sized water bottles used over the course of the year to clean the ice. Now, the way a Zamboni operates is that it drags a blade over the ice surface, removing a thin layer of ice, and then transferring its ice shavings into a storage tank, while simultaneously dispensing the fresh water onto the ice surface, which results in a clean and smooth skating surface. Now we're going to show you a quick video of how it is Zamboni works. Alright, so the video doesn't want to load, but that's fine. Basically what it does is it takes a blade, drags it across the ice, collects the snow, dispenses water back out. But the snow that's collected is then dumped outside and it's wasted. What we're proposing is to take a system that takes the wasted snow shavings and recycles it into reusable water that eliminates the use of fresh water to clean the ice and reduces the university's water footprint. Mike's going to tell you more about how the ice cycle system works.
Thanks, Kevin. I'm going to talk about how we are implementing the ice cycle system into the Zamboni, as you can see in this picture. Obviously, we need a heating device, which is going to power off the Zamboni's battery. So what happens is when the shavings are thrown into the snow tank, the heating device is going to melt the snow, turn it into water, and the water is going to filter through this filter right here and into the water tank. Once it's in the water tank, it's going to go through a pipe and dispense on the ice. A key element here is the ability for the Zamboni driver to control the heating device, because if the heating device heats up the water too much, it'll boil the water, and in turn, it will evaporate. So we want to keep it at a certain point of heat. So Adam right here is going to talk about the resources that are needed to implement the ice cycle system.
All right, thanks, Mike. So in order to implement our ice cycle system, we need wires that go from the battery from the battery to the heat device and to the operator. This allows him to fully control the heating device while it's in operation. So then we have the heat device, which is the crucial element to our system, and then a series of filters and pipes that ensure only clean and usable water hits the ice surface. Now, accessibility of the resources. All of the products that are needed to fulfill this system are actually easily acquirable from your local hardware store, with the exception of your heat device. We found that you need to purchase that from a supplier in Chicago named Winesco. They produce a heat table that's of industrial size and strength, suitable to melt the quantity of snow that we're producing. Now Herbert's going to take you through the value of the product.
All right, so I'm going to talk about the value of the product. And one of the great values of the product is it's less labor intensive, because the driver doesn't need to open and close. He doesn't need to open and close the Zamboni after when it's time for collecting the ice, so which is labor intensive. So, and then the other issue we're solving here is it's less time consuming, because it's a recyclable system. So which means if it's a recyclable system, the driver doesn't need to open and close as well. Because it's already it's a recyclable system, and because this is a sustainable clean system, it puts St. Mary's it makes St. Mary's as a green university. And then the other in general, the other issue is that it conserves, it protects from water wastage, which means that like Kevin said earlier in the presentation, that this system saves 700,000 waters of liter a year. So we think this is a great system for water conservation.